Have you ever stopped to wonder, how did the sun, the source of our existence, come into being? Our sun's story is an epic tale that began some 4.6 billion years ago. Back then, a vast molecular cloud, a region dense with matter, began to collapse under its own gravity. Picture it like a cosmic dance, where particles swirled and twirled, drawn together by gravitational attraction. As this cosmic ballet continued, most of the matter began to congregate at the center of the formation. The rest of the matter, not to be left out of this grand performance, flattened into a spinning disk orbiting the central mass. This orbital disk would later become the solar system we know today. Meanwhile, the central mass grew increasingly hot and dense under the immense pressure. So hot, in fact, that it sparked a process known as nuclear fusion in its core, causing it to glow with heat and light. And thus, the sun, our very own star, was born. But what keeps the sun burning and shining day in, day out? Well, the answer to that lies in the heart of the sun, its core. Here, a process called nuclear fusion takes place. This is where the sun's true power lies. In the core of the sun, temperatures reach a staggering 15 million degrees Celsius. This extreme heat and pressure cause hydrogen atoms to come together or fuse, creating helium. This process is known as nuclear fusion. Now, let's talk numbers. Every second, approximately 600 million tons of hydrogen fuse into helium. That's a tremendous amount. But what's even more astonishing is that this process converts around 4 million tons of matter into pure energy. Yes, you heard that right. The sun is a colossal energy factory, churning out immense amounts of power every single second of every single day. This energy is what makes the sun shine. But here's an interesting fact. The energy produced in the sun's core doesn't immediately reach us. Instead, it can take between 10,000 to a whopping 170,000 years for this energy to escape the sun's core and make its way to the surface. Once it reaches the surface, the energy is then emitted as light and heat. This radiant energy travels through space, taking about 8 minutes to reach us here on Earth. This light and heat from the sun are the driving forces for life on Earth. They provide the energy needed for plants to photosynthesize, creating oxygen for us to breathe and food for us to eat. But not only that. The sun's energy also drives our weather patterns and ocean currents, and even powers our homes and cities through solar energy. So, the next time you feel the warmth of the sun on your skin, remember the incredible nuclear fusion process taking place millions of miles away in the sun's core. So, the sun's ceaseless glow is a testament to the power of nuclear fusion. As with all things, the sun too has a life cycle. What does the future hold for our fiery celestial companion? In the distant future, the sun will experience a significant change. When the hydrogen fusion in its core diminishes to the point where the sun is no longer in hydrostatic equilibrium, its core will undergo a significant increase in density and temperature. This increase will push the sun's outer layers to expand, marking the beginning of its transformation into a red giant. Now, what does this transformation mean for us on Earth? Well, as the sun expands, its radiant energy will increase, rendering Earth uninhabitable. The oceans will evaporate, mountains will melt, and eventually the Earth might even be engulfed by the sun's outer envelope. A grim prospect indeed. However, the sun's story doesn't end there. After swelling into a red giant, the sun will shed its outer layers, casting them off into space. What's left will be the sun's core, now a white dwarf. This dense, hot core will no longer produce energy by fusion, as it did during its main sequence life. Instead, it will glow and radiate heat from its previous fusion reactions. This glow will last for trillions of years, a testament to the sun's past life as a main sequence star. But the sun's evolution won't stop there. After trillions of years, when the white dwarf has radiated all its residual heat, it might become a black dwarf. This hypothetical celestial object would be extremely dense and give off no more energy, effectively marking the end of the sun's life cycle. In the grand cosmic timeline, our sun has lived half its life, and its future transformation will be a sight to behold, even if we won't be around to witness it.